Hey everyone, yeah, yesterday I was giving the weekly context for 484 and I was able to solve the three problems, and for the fourth problem I was able to figure out some stuff. Then I was just lazy and I had to have dinner, so I just skipped it. So yeah, maybe we'll just today probably start with doing the PODD and then probably just read through the chapters, two of the Headfirst design. So we're starting observer panel today. Let's just see how it goes. Let's see. So yeah, first let's start with the theory. So on a 2D plane, there are endpoints with integer coordinates x, y, and yi. Return the minimum time in seconds to visit all the points in the order given by the points. So you can move according to these routes. In 1 second, you can either move vertically by 1 unit, move horizontally, move diagonally, square it to 2 units. In other words, move 1 unit vertically and then 1 unit horizontally. You have to visit the points in the same order as they appear in the array. You are allowed to pass through points that appear later in the order, but these do not count as visits. Okay, so for example, here we can possibly uh, we are going to start from. So one optimal path is that we'll start from 1 comma 1, go to 2 2 2, 3 4, minus 3 and 4 right here. This is minus 1 0, and um, okay, cool. So from going from here to here, it will take around, for example, we'll have to go from 1 comma 1 to 3 comma 3. That would take us almost um, like 3 seconds or maybe 2 seconds, because that's like 1 plus 2 and then 1 plus 2 here. So that would take us 3 seconds, 2 seconds for that. And then we'll have to go up, so that would take another 1 second. So that is 3 seconds to go from here to here. As you can see, 1 2 3, and then we have to go from 3 comma 4 to minus 1 comma 0. So that would be going from, first of all, we'll have to go to something like, again we'll just have to try to go and so going diagonally is the best possible way for us. So we'll just go diagonally. So we'll go 3 comma 4, then it will be 2 comma 3, and then basically if we just go to 0 comma 1, that would be around 3 points again. So that's like 3 plus 3, that's a 6. And then again, if we go 1 point, then will be that will be that. So yeah, so technically this is how we can do it. Yeah, so for going from 3 to minus 2, that is going to take us around 5 seconds. Yeah, and we can probably consider this also. So it's just going and adding values honestly to the thing, uh, possibly we will do that. So let's just have an answer. Let's just have a variable answer. And we're just going to go for all the points. So basically, answer will be added in that direction. So technically, I'll go for each and every point inside the overlay, and then possibly we'll just since we're starting from the first point, so I have to ignore that. Yeah, we'll probably uh, let's just start with uh, let's put I one as a points dot size and the plus, and then we'll just have uh auto auto type equals points of I comma uh, points of I, and then auto then b equals points of 1 minus 1. So these are the 2 points that we have, and then we'll calculate the MNX. as the minimum of basically so it's it says possibly absolute of basically points current of zero minus uh, previous of zero and then finding MNY equals absolute of one minus previous of one and then possibly we are going to have the maximum of MNX and then Y the answer. We'll probably just take on the answer. Should work. Let's just see if it works or not. Okay, that's good. So yeah, that's what's the problem for today. I think it was a good problem in order to think about the problems. So yeah, I think the only thing that was good about this problem was the fact that we only had to take care of the additions and all this stuff. We could have prevented using absolute although we could have just relied on the if operations, but I don't know, maybe they're not very important for us right now. So yeah, that was the priority for us. So let's continue with the keeping objects in the know. We'll do this for 15 minutes then. So I'm just set a timer, 15 minutes. 15 minutes timer for today now. Let's just walk through it. Yeah, so quite possibly let's start with it. So second chapter, the observer pattern. Keeping your objects in a Hey Jerry, I'm notifying everyone that the patterns group meeting moved to Saturday night. We are going to be talking about the observer pattern. The pattern is the best. It's the best here. So don't miss out when something interesting happens. We have got a pattern that keeps your objects in the know when something they might care about happens. Objects can even decide at runtime whether they want to be keep informed. The observer pattern is one of the most heavily used patterns in the JDK and it's incredibly useful. Before we are done, we'll look at one-to-many relationships and loose coupling. Yeah, that's right. We said coupling. With observer, you will be the life of the patterns body. So congratulations, team has just won a contract to build Weatherorama incorporate next generation internet-based weather monitoring system. So Weatherorama incorporate underways the Eternal Valley. Okay, 45021. Congratulations on being selected to build our next generation internet-based weather monitoring system. The weather station will be based on our pending weather data object, which tracks current weather conditions, temperature, humidity, and barometric pressure. We'd like for you to create an application that initially provides three display elements, current conditions, weather statistics, and a simple forecast, all updated in real time as the weather data object acquires the most recent information. Further, this is an expandable weather station. Weatherorama wants to release an API so that developers can write their own weather displays. We'll plug them right in. Would like for you to supply that API. Rama thinks we have a great business model. Once the customers are hooked, we intend to charge them for each display they use. Now, for the best part, we are going to pay you in stock options. We look forward to seeing your designs and our final application. Sincerely, the CEO, we are overlining the weather source files for you. So the better model application model. The thing is the system on the weather station, the physical device, and the actual weather, the weather data object that tracks the data incoming from the weather station and updates the display that shows the user the current weather conditions. We have a weather station that pulls the data from the weather object, and we have display device that displays the conditions of the three different displays. The user can also get the weather stats for and forecast. So we have display device, we have weather temperature, and we have a weather station that basically takes care of the humidity sensor device, the temperature sensor device, and the pressure sensor device. So, okay. So this is what the weather or armor provides, and what we implement is the weather data object and the display device. So weather data object knows how to talk to the physical weather station, how to get the updated data. The weather data object then updates its data for the three display elements, current conditions, soil temperature, humidity, and pressure, weather statistics, and a simple forecast. Our job is, if we choose to accept it, is to create an app that uses the weather object to update the three displays for the current conditions, weather stat, and the forecast. Unpacking the weather data cloud. As promised, the next morning, weather data source finalized. Speaking inside the code, things look pretty straightforward. We have a weather data that has a get temperature, get humidity, and get pressure, and measurements changed. I think it's probably a Boolean that we measure on the most recent measurement for the temperature, humidity, and pressure. We don't care how these variables are set, or the weather update, no matter how to get the updated value from the weather station. This method gets called whenever the weather statements are updated, probably called weather change. The developer of the weather data object left us a clue about what we need to add. Remember, the current condition is just one of the three different display conditions. So, current conditions is temperature, humidity, and pressure. Our job is to implement measurements change so that it updates the three displays for the current conditions, weather stats, and the forecast. We don't so far. The spec from weather are more than all that clever. We need to figure out what we need to do. So what we need to do, the weather data class has a getter methods for three measurements, temperature, humidity, and barometer pressure. The weather measurement change method is called anytime new weather measurement is available. We don't know if the method is called. We don't know. We know that everything. We don't know how this method is called. But we know get temperature, get temperature measurements. So display one is the current conditions, temperature, humidity, and pressure. Display two is average temperature, minimum temperature, maximum temperature, and display three is forecast. Okay, we need to implement the three display condition using the current condition display, statistic display, and the forecast. These displays must be updated each time the weather data has a new variable in the system. It must be expandable. Other developers can create new custom displays, and users can remove many displays they want from the application. Currently, we know that only selected the current conditions, statistics, and forecast are available. So taking a first Miss Curtis swag at the weather station. Here's the first implementation possibility. We'll take in from the weather program developers and our code management chain method. Public class weather data, weather measurement change, flow temperature, get temperature today, flow pressure is equal to get pressure, and grab the most recent measurement by calling the weather data getter methods already implemented. Um, Current conditions the display update temperature, humidity, and pressure. Statistic update temperature, humidity, pressure, and forecast update temperature, humidity, and pressure. Other weather data methods are based on our first implementation, which are the following apply. We are coding to concrete implementation or interfaces. Okay, we are going to go one by one then. For a new display element, we need to alter the code. Uh, no, I'm not sure about this because for a new display element, we need to alter the code. I think we're not even talking about display right now. So this is something that I don't really need to care about. Hmm. We are violating the encapsulation of the metadata class. We haven't included the path changes. Hmm. We are coding to concrete implementation, not interfaces. Well, we don't really need to we don't really need to consider this now. Do we need to? I don't think we need to do that. No, we have no way to add a display elements around that. This is probably one of the things. Um, if the display elements don't implement a common interface, yeah, this is probably one of the thing. We haven't encapsulated part of the change. We are violating encapsulation of the data class. Well, yeah, we haven't. So let's just let's answer ChatGPT. You can just tell us if we have marked them correctly. Um, uh, Please don't have any jargon involved in emojis. Just plain as paragraphs and questions. And we'll do that. Now, the line, nouns, conventions, then see. Um, hmm, was the first implementation. The minimum change method, whether data class directly calls the current display method. Mm, okay. There are specific concrete display objects whether data knows exactly which display exists and how to talk to this. The code where the system is tightly bounded to specific display classes instead of. Mm, for every new display, now we need to alter the code. If you want to add a new display, for example, health index display, heat index display, you must write the measurement change methods and add another display update code. This means changing existing code every time requirements are over. Okay, you know way to add or remove display elements at rotate. The displays are fixed at the validated data class. There is no mechanism directly register them. The display elements are not given the command line. Even if the display classes happen to share an update method with the okay. Providing this and then we are coding to any players. This also is true for got it. What's wrong with the implementation? Think back to all those chapter one concept principle. Measurement change, flow temperature, get temperature, all this stuff. Current condition does display. Area of change, we need to encapsulate this. At least we seem to be using a common interface to talk to the display when they all have an update method, bugs, temperature, values. According to concrete implementation, we have no way to add or remove the display elements without making change to the program. I don't really understand this thing. I hope you explain this thing. Then help me understand this. And even on what examples, for instance. Think of it like this in a simple area. Right now, the weather data class I have a manager who knows the names of all of every employee in each and calls each one individually in the whole weather data is incorporated. Never forgot it. It does this by one man current display level. Because of this weather data is tightly tied to this exact display objects. It does not know that there are some displays. It knows exactly what display is. Why is this a problem? Imagine you have to add a new display. Go back to the class and change it. You have to add another line, which means that every time update is argument, you must modify the existing code. Even worse, if you want to remove display, you will have to go back and because function is machine. And that's important for you when you cannot add or remove displays at one time. The displays are hard coded into the method. There are no list of display, no regulation processor, no way for display to say I want to be this, I don't want to stop everything in there. So if a program is running, can I reach a new display dynamically? You cannot detach an existing display dynamically. The only way to change the display is to stop the program and deliver the data for recompile and run again. According to concrete implementations really mean here is that whether data depends on specific classes, not on general idea of the display. It is written in the work only with the three exact display types, and if one of the changes, a more flexible approach would be for whether they have to only know that it has some displays that all follow the same images around it, they would not care about how many are there and what are they. Similar, the current images are items like also low one. If you want to add removal, you must make the wall. The value there is to use the sockets even plug upward and unpluggable, not changing the wall. Okay, got it. At least we seem to be using a common approach. I know I am new here, but given that we are in the observer panel, I will maybe use that. We'll take a look at the observer, then come back and figure out how to apply it. Read the observer panel. You know how newspaper or magazine subscriptions work? A newspaper publisher goes a newspaper publisher goes into the business and begins publishing newspaper. You subscribe to a particular publisher, and every time there is a new edition, it gets delivered. Newspaper publisher goes into business. As long as you remain a subscriber, you get newspapers. Even subscribe when you don't want papers anymore, it's not being delivered. While the publisher remains in business, people who have their line additional currency or the newspaper. Publisher for subscribers is equal to the observer pattern. If you understand newspaper subscriptions, you pretty much understand the observer pattern. Only we call the publisher the subject and the subscribers the observers. Let's take a closer look. Subject object manages some bit of data. When the data in the subject is observers are multiplied by object category more observer objects. The observers have subscribed a register to the subject to receive the object and the subject object. New data values are communicated to the observer in the form they change. The object isn't an observer, so it does not get notified when the subject data changes. A day in the life of an observer pattern. A dark object comes along and they have the subject that it wants to become an observer. Clearly wants to exception. Subjects and coordinates check to celebrate. This is just subscribe me, subject object. The duck object is now an official of the duck side is on the rating of the data. The subject gets a data value, and all the rest of the observers get a notification. When the subject is the mouse object asks to remove as an observer. The mouse object has been getting in storage and is tied up. Therefore, it decides it's time to stopping out the model out. So much the subject is another new event or the observer state. Alright. 5 minute drama. Yep, we'll start with 60 in the next video. Thank you so much for watching. Hope you have a wonderful day.